So log funcations or just functions. Okay. To find the inverse function algebraically, what do we have to do with our x and y? Switch them, yeah. So interchange x and y in the original. In the original equation. Okay, and then we could solve for the y. So we're just reviewing what stuff you've already should know. So graphically, it's going to be a reflection in which line? Reflection in y equals x or x equals y. Yeah. But we still would, and then we would also interchange the x and y coordinates. So for example, if on f of x, we have a point of 2, 6. On the inverse, what would it become? 6, 2. Yay! Okay. So find the inverse of this function and sketch. So I provided the y equals x line for you. So if we wanted to plot this line, what's the y-intercept? Negative 6, 3, 4, 5, 6. And slope is up to right 1, right? The number in front of x. It's our slope. If we derive that, you would get your slope equation of y equals 2. Y prime equals 2. So up to right 1. Up to right 1. Okay, this is nice because we can get our y and x intercept, which are going to be inversed. If you have a ruler, it's really helpful. If you have a smartboard, it's also very helpful.
I have one.
A smartboard? That is convenient. You lucky duck, you. Okay. Okay, so the inverse function. On the graph, if our y-intercept was negative 6, that means now my new x-intercept is negative 6. If my x-intercept was 3, my y-intercept is going to become 3 because the x and y switch places. So that's the easiest way to sketch it. And then you just need a line. Let's use red. Oops, I need a line. Okay. Oopsie. Oopsie. There you go. Okay, and the point y equals x, what do we call that point? It has a special name. Can you take your ear things out, Landon? Yep. Invariant. There is no variance. Invariant. Okay. All right. Easy? Easy. Okay, so properties of inverse functions. Since x and y are switched, the domain becomes the range, and the range becomes the domain. They switch as well. Another note, if I had the inverse of my original, okay, that would just equal x. So it's basically if we, so for example, do you want me to give you an example? If we look at our original function, if I want to find f of 3. Okay, so what was f of 3 on our original function? So at 3, x equals 3, what was our y value? 0. And so on the inverse function, when x is 0, what was y? 3. Okay, so you're going back really to the original equation. Okay, we gotta do a little bit of limits. Yay. All right, good old changing forms. If you have, we'll use x. How would I change this to exponential form, this log? E to the power of y equals x. Yeah. So some log laws. What would this be equal to? X. Yeah, because it'd be x log b of b, which is just 1. So this would be equal to x. As long as our base, what has to be true about our base? Yeah, it has to be the same as this. And when we have bases, right, they can't be a negative number. Right, and it can't be a 1, a base of 1. An x element of the roots. Okay, how about the next guy? Have you seen this one before? It is also equal to x, for x is greater than 0. I'm going to show you. Okay, so b to the power of log bx, we're going to call this y. Okay, so I'm going to change this. Well, we can take the log of both sides. One way we can approach this. Okay, if I take the log of both sides, what happens here? Oh, this is a. Oh, I should actually. Let's use exponential form. Sorry. So if it's exponential, changing it to log form, my base is b of y. This is the best way to prove it. So my base was b of y equals log b to the x. Therefore, what can we say?
Y equals x.
Y equals x. So this would equal to x. Okay, so the easiest way is actually change it into log form. So log, I put my base of b of y equals the exponent. Okay, when our base and our answer are the same, it has to be raised to the power of 1. B to the power of what equals 1? 0. 0. So since b to the power of 1 equals b, and since b to the power of 0 equals 1. Okay, so logs. We're looking specifically at this is y equals b to the x. We know that logs and exponential functions are inverses of each other, right? We talked about that yesterday. So if we had, and this would be then y equals log b of x. So here's our two graphs. So as x approaches, we're looking at our log graph. As x approaches 0 from the right, what is our graph approaching? Our y value approaching? Negative infinity. Okay, and as we approach positive infinity for x, our y value will approach positive infinity. It'll take a while, but it'll get there. It'll still get there. Okay, so these are going to be really important concepts we're going to use. Okay, what's your domain of, we'll say, the log function? Will be x is greater than 0, range is YER. Okay, and we just talked about these guys already. Okay, so the common log is base 10. Just written as log x or log 10 of x. Okay, so if we have log 10 to the power of x, what would that be equal to? Just x. Good. And new one for you. What would this be equal to? X as well. Okay, so log laws, these were on the board. They're actually at the front here too. So this is our power law, right? Then we have, which one, what's this called? The next guy called? Product, and the last is quotient. So log x plus log y and log x minus log y. I love logs. They're so much fun. Yeah, I don't know. There's another formula that's change of base, right? So if our base is not 10 and we want to just punch it into our calculator, we can use change of base, which is log x divided by the log of our base. Oh, no, write this. The reciprocal of log x of a. Natural logs, we talked about Euler a little bit yesterday. So that's a natural log of x, which is a log with base e. For x. Oh, ln. ln. This is natural log. Here, ln of x. Sorry. ln, L of n. So we can carry our laws down. So what would this guy be equal to? X and x, right? Good. So natural log of b dx, the same laws apply. So we can go x times the natural log of b, go natural log of x plus natural log of y. Am I recording? Yes, we are. And then subtraction. So all the same rules apply, whether it's a natural log or it's common log. Common log. Okay, so now some fun stuff. I hate blah, all this stuff, especially when it's review. It's like, oh, how exciting. Yeah?
We can still use normal logs instead of using ln?
Yep, you could use either or. There's benefits to using natural logs in certain situations, and there's benefits to using natural log in certain situations. Usually those situations depend on which base you have, e or 10. If your base is anything but those two, then it really doesn't matter. Okay, so let's solve these. Do you like these? I love these. These are always so much fun. I need to get out more. Clearly. Clearly. It just doesn't. Sorry. Typing issue. Okay, so when you're solving for your exponent and we can't use change of base and we don't want to use our graphing calculator, why? So you don't get one, you're in calculus. How can we solve? Well, we have to use logs. So we do what to both sides?
Log of 5.
Yeah. So if m equals n, we're using the rule of m equals n, then we can say log m equals log n. Is that how you were shown in, or did you actually use like, change it to exponent or exponent?
Yeah. No, we just log 2 to the 3 equals x.
Yeah. Oh, okay, so there's two options. I'm going to show you both. I think you're going to like this other one better. So there's the usual where we looking for exponent. So we're going to take this. We're going to make a base of 2 of 3 equals x minus 5. Totally legit. Okay? So so we use change of base, log 3 minus divided by log 2. We add 5, and that will give us our x value. Right? Get x by itself.
Yeah.
Right? Good?
Yeah.
Too much at once. No. Okay. Okay, so yeah, it's legit. You can use it. Yeah. That. Plus 5. So our x value is 6.584. I'm going to show you one other way. And that's using the above. If m equals n, then we know log m equals log n. Okay? So, or m equals n, natural log of m equals the natural log of x. So this equation, would I use natural logs or logs?
Log.
Doesn't matter. Let's use natural logs because it's base e. Okay?
How do we know it's base E?
Because it's
Oh, that one. I'm looking at that.
Sorry,
Looking at
sorry.
number 1.
okay. So because these are equal, then their logs are equal. We can take the log of both sides. It's a natural log.
Log. Log.
Okay, and we can use power law here. We'll get. You can skip that step if you like. Okay, so I use power law. I want x by itself. What would I divide it by? Or actually, what is natural log of e? 1. So negative x equals natural log of a half, or x equals. Yes, you do. They all do. They all do. Just gotta find it. So negative natural log of 1/2. What? 6 now. Okay. Okay. So we can take the natural log of both sides and then just use our log laws from there. So you might like that. I don't know. This guy. X equals 2. Yeah, we're just going to bring the 2 down. Okay, and natural log of e is just 1. So we get 2 times 1. Just 2. So here's an example. I'm solving for my not diagonal. This we could just type in. That's boring.
We can use my log formula program.
You don't even have to type it in.
Do it anyway. Well, I guess you can just do it like this.
If you want to, we want to simplify this thing. We could take the natural log of both sides. No, sorry, mad.
What if we replace 3 and x? So put x on the
Honestly, if you want to make this easier and solve this algebraically, we can take the natural log of both sides. I'll show you why.
81.
Okay, so this would come down. What would happen to natural log of e? It's equal to 1. Okay, so I want these to be equal. So what can I do with the 4? 3 to the 4. So we can then therefore say, 3 to the 4 equals x, which is 81.
Wait, so what did we just learn instead of number 1?
Take the natural log of both sides. So, you know when you had problems like this, have you seen ones like that before?
Yeah.
Yeah. Take the natural log of both sides, right?
Instead of taking the common log of both sides?
Or sorry, common log of both sides is easier. You could do either. They're just same. Let's use common log because it's not base e. Okay. So now what?
X minus 2 log 2 equals x.
So bring down our power. So x minus 2 times log 2 equals x plus 5 log 7.
I can just figure out what log 7 and log 2 are. And just start down the root.
You could do that. We need to distribute. So x log 2 minus 2 log 2, because that we were trying to isolate x. So x log 7 plus 5 log 7. Okay, all the x's on one side. What else would you do?
I would just figure out what log 7
Log 2
are.
actually is.
And then,
Algebraically.
but it's going to be a decimal. So if I ask you to express this as an exact value,
Store log x.
right? If you're asked to answer it with you have to be able to do this work though. That's all I'm saying. Can you do this? And then factor x out, divide. Okay, so you have to be able to do this. That's why taking the log of both sides can be very helpful. Right? So that would be the exact value answer if I asked for an exact value. Yeah, if you type this in, it's going to give you an ugly number. Yeah, could you still solve? Yeah, if I'm asking for the decimal. Okay, so if it's an exact value, that would be the answer. All right, moving back. Didn't we do this already? I feel like we already covered this stuff, okay? Can we? Oh. Okay, let's do this one. First step, before you can ever combine logs or use the first two laws, notice the first two laws only work if the log is by itself. There's nothing in front of it except for a plus or a minus. So your first step is to get rid of these ugly numbers in front. And how do we do that? I think you know, right? We're going to raise it to the exponent. Guys, plus log y to the 1/3 minus log. Tyler, you with us? Come back. So before you can use any log laws, you have to deal with the power law first. It takes precedence. Yeah, that's a good word. Okay, so now can we combine them all under one roof? Yeah? Who's going to be on the numerator? X squared and cubic root of y. Because they have just a plus sign in front of them, and the x plus minus 2 to the power 4 has a minus, so it becomes x minus 2 to the power 4 on the denominator. Easy? Takes clear as mud. I like that. Okay, natural log, we want to expand this. Let's expand this. So first we're going to deal with product and quotient when we're expanding it. So everything on the numerator is going to have a what in front? Plus or a minus? A plus. So natural log of root x plus natural log of 5 plus natural log of y. So we're breaking them apart. Minus, everything on the bottom is going to have a minus in front. So natural log of z minus natural log of 3x plus 1 squared. Okay. So we want to simplify this so that there's no exponents. So what would we do with this guy? Question, Graham. Question?
I can't read it. ln.
This one?
Yeah.
That's a z. Natural log of z. Sorry. Yeah. Thank you. So we're going to put the 1/2 in front. This one's good. This one's good. This one's good. And put the 2 in front of the natural log. Okay, so that's it for today. It worked out well because it's a short day.
Since it's a short day, I think we should knock off the first line.
No. The first line is the only line of homework.
Look at graphs.
Just reading. Okay, so your homework is page 375. Do you want to open up to 375? So numbers 3, 4, 5 AC, 6, 9 AB, 10, 11, 12. Well, let me open up your books and then I'll consider.
The first line, it's like half as long as normal, half as much.
Okay, homework is good practice. 375?
sorry.
Don't eat three pretty big. That's horrible.
Okay. Assignment is number 3. Those are easy. 4. Guys, really? It's not that bad.
Knock off one question.
Easy,
But there's so many. Why don't you just do like follow
What do I do with yesterday's homework? I still think read 8.3, look at
Okay, you can omit number 10
11 and 12.
and 11. Okay, you can omit number 10 and 11. So your homework is 3, 4, 5. Oops. You're welcome. 9A, B, and 12.
Why does nobody say that?
So eliminate 10 and 11. So you got 10 minutes. Let's go. Let's get something done. You can start on your assignment. There might be some stuff on there. Yeah. Remember, I'm taking in homework, so you have to show me by the end of the unit. Anytime. And if you finish in class 6. Okay? Yes, you may. Wiley? Let me know when you're going, guys. Just let me know.